Okay, we're going to do oxidation number here, and we're only going to focus on carbons. Okay, I'm going to show you the way I do it. For carbons, this should work every time. I think it's a simpler way of doing it. Maybe there's one question in the assessment about this, but we're just going to focus on carbons, organic compounds. Probably have experience with this in Gen Chem, but looked at inorganic materials. I made some random. You can make whatever you want for practice. Quiz someone you're studying with and identify carbons to. This first example, we're going to identify the oxidation number on each carbon listed: blue, purple, red, and green. And then here we have some sort of reaction, either an oxidation or reduction, and we'll see if our carbon was reduced or oxidized. So our first example here, we'll start with our blue carbon. The way I do this is I write all 4 bonds that carbon is making. So this carbon here, I see it as making a bond to oxygen. It is making 2 bonds to oxygen up here. So 1, 2. Here's my alcohol oxygen. Here's my ketone, carboxylic acid. So all 3 oxygen bonds in my carboxylic acid bonded to carbon here. 1, 2, 3. And then my carbon is also bonded to 1 carbon on the right. Okay. If the heteroatom is more electronegative than carbon, it is more electronegative. So here's carbon, here's nitrogen, here's oxygen, here's fluorine. All of those are more electronegative as we go right across the periodic table. If it's more electronegative, they get +1 each. If it's carbon, it cancels. And my oxidation number for this carbon is simply +3. Okay? If it's more electronegative, in respect to carbon, our carbon will get +1s. They're more electronegative. Our oxygens are more electronegative. They're pulling electron density away from carbon. They're pulling electron density away from carbon at negative charge. So the carbon is in result more positive. Think of it like that. And our oxidation number, carbon, is +3. And we know that we're doing these oxidation reactions. We can oxidize, say, an aldehyde, or even an alcohol up to an aldehyde, and then all the way to a carboxylic acid. So it makes sense that our carboxylic acid has a high oxidation number. Okay? You can try the purple one on your own. If it's more electronegative, okay, it gets a plus charge. So carbon, oxygen, nitrogen, any of our halogens, all those are going to get +1s. Anything less electronegative than carbon is going to be -1. So like mainly hydrogen. Hydrogens are going to be -1s, and our carbons will cancel. So this purple one here, our 4 bonds are oxygen, carbon, carbon, and hydrogen not drawn in. Our carbons will cancel. Oxygen's more electronegative than carbon, so +1, and our hydrogens are -1, right? If we have carbon, if we have methane, 4 bonds to hydrogen, we'd be -4. Methane's the most reduced a carbon can get, and that makes sense, -4, so on. Carbon dioxide, 4 oxygen bonds, that would be +4. That's the most oxidized a carbon can get. So our oxidation state on this purple one here, +1, -1, 0. We got a little practice with double bonds here. We'll do it again with our red carbon. Okay, our 4 bonds. I have 2 to carbon, 1 to bromine, and another to carbon. Carbons cancel. Bromine is more electronegative. It is +1. Oxidation state on this carbon +1. our green, our nitrile carbon right here, is making 3 bonds to nitrogen and 1 bond to carbon. Carbon cancels, nitrogen is more electronegative than carbon, so each one gets +1. Total oxidation state for our green carbon is +3. Pretty straightforward, okay? Now, we'll look at an example down here, and we're looking at our blue carbon, noted here, and we're asked if this carbon, or in respect to carbon, whether this reaction is a reduction or an oxidation reaction with respect to this carbon, okay? So again, I'll do the same thing. What are my 4 bonds that I'm making? Carbon, right here, oxygen, and then 2 to nitrogen. I can then go over here. What are my 4 bonds? Carbon, 1 to nitrogen, and then 2 to hydrogen, not drawn in. Okay? So my oxidation state to begin with, carbon's going to be 0, oxygen's going to be +1, nitrogen +1, nitrogen +1, very oxidized at the beginning, +3. And then at the end, carbon will be 0, nitrogen will be +1, and hydrogens are going to be -1 each. So that gives me a total of -1. Am I oxidized or reduced in this case? This is going to be a reduction at reaction. So, reduction. If you have more hydrogen bonds at the end, you're reduced, right? And alkane, methane, all those are going to be the most reduced you can get. Usually the more bonds, well, notice that our +3s, just visually, double bond to oxygen, triple bond to nitrogen, okay? Double bond to nitrogen, bonds to oxygen. So bonding to more electronegative heteroatoms are going to get us high oxidation numbers. Bonds to hydrogen, reduced, saturated, those are all going to give us low numbers or reduced numbers. Okay, just worry about carbon for now, and I think if there is a problem on the assessment, I think this one would be an easy point, hopefully. So.